Just take a look at the surroundings. Don't you see the flower of development blooming? A large number of such scenes. Do you know what has worked behind to achieve all this? Is it not different forms of energy? It is a wide varieties of use of different forms of energy that has led to the development of modern society. There are different forms of energy. Among them, the most important one is electrical energy. Don't you see the hands of electricity around us? What is needed to make a bulb in a vehicle glow? Is it not electricity? When an engine of a vehicle works, it makes use of electrical energy stored in a battery. This electrical energy stored in the battery is obtained by the working of a small generator in the vehicle. You need electrical energy to make your mobile phone work, isn't it? It is electrical energy flowing from the battery that makes a mobile phone work. Electrical energy is essential for the working of towers as well. You are aware of the fact that a TV works making use of electrical energy. A camera is essential for converting scenes into signals. The camera needs electrical energy for its working. In a battery of camera, chemical energy changes into electrical energy to make the camera work. It is by using the electrical energy that the refrigerator, the mixie, and several other devices are working. Haven't you noticed one thing in common in all these? Electrical energy can easily be converted into many other forms. This is a major advantage of electrical energy. Electrical energy does not make atmospheric pollution. During the transmission of electrical energy, there is neither dust nor smoke. Take a look at the effects when devices are made to work. When you switch on an electric fan, the electrical energy changes into mechanical energy. The rotating leaves of the fan gives a wind. When you switch on an electric lamp, electrical energy changes into light energy. Some heat energy is also formed. Do you know what happens while you're charging a mobile phone? Electrical energy changes into chemical energy, isn't it? In a mixie and a grinder, the electrical energy changes into mechanical energy for its working. In a microwave oven and the induction cooker, the electrical energy changes into heat energy in special ways. Not only at homes, but also in industries, shops, petrol pumps, etc., we make use of electrical energy. There are many other situations in our daily life where we are making use of electrical energy. A batter gives a small amount of electrical energy. A small generator is also like that. But there is production of electrical energy on a large scale in power stations. It is transmitted to different places, even at a distance through transmission lines. There are power grids as well to transmit electrical energy from place to place. You know that generators convert mechanical energy into electrical energy. When the mechanical energy is given to a generator making use of energy of falling water, we call the power station a hydroelectric power station. We make use of energy of water by constructing dams, trenchware, etc. Nowadays, windmills are also used, which make use of energy of wind for the production of electrical energy. There are solar power stations too, which make use of solar energy for the production of electrical energy. For this, we make use of photovoltaic cells, which are working on the basis of photoelectric effect. For this, we use solar panels. In these, the electrical energy obtained is stored in battery units. This makes a continuous flow of electricity possible. Yes, the electrical energy has become a good and true friend in life. It is the use of this true friend and its effects that helps us in many of our works, making your life so comfortable. Electrical energy can produce heat energy as well. This is a heating effect of electricity. Let us try to do an experiment for understanding the heating effect of electricity and the factors affecting it. Take a look at this circuit. In the beaker A and B, there is 100 ml of water. PQ is a nichrome wire and RS is a copper wire. There is a thermometer in each beaker. Now the switch is turned on. After 3 or 4 minutes, we can see from the thermometer reading that the water in the beaker having nichrome wire has become hotter. From this we can understand that PQ, the nichrome wire, has become hotter than copper wire. The same current 1A was flowing through each since they are in series. When same current flows through different resistors, the resistor having higher resistance gets more heated. That is, resistance is a factor that affects the heat developed in a current carrying conductor. This can be expressed as H proportional R. Now, let's pour out the hot water in the beakers and fill 100 ml of water at 30 degrees. This time, we make the current 2A. Let us pass current for 3 minutes. Formerly, the water in the vessel having nichrome got heated up to 36 degrees only, while now it has become 40 degrees. That is, the increase in current has increased the amount of heat. Hence, current is one factor that affects the heat developed in a current carrying conductor. The symbol of current is I. The heat is directly proportional to the square of the current. It can be expressed as H proportional to I squared. What if the time taken for the flow of current increases? Let us take a look at the thermometer after 7 minutes. We can see that the water has got heated up to 44 degrees centigrade in the beaker having nichrome and 37 degrees centigrade in the beaker having copper. Isn't this proving that the increase in time increases the amount of heat? That is, time is one factor that affects the heat developed in a current carrying conductor. This can be expressed as H proportional to T. The scientist James Prescott Joule formulated the Joule's law, connecting all these ideas. The law says that heat generated in a current carrying conductor is equal to the product of the square of the current I in the conductor, the resistance R of the conductor, and the time of flow of the current, which is T. If H is a heat developed in Joule, then H equals I squared RT, where I is a current in ampere, R is a resistance in ohm, and T is a time in second. Using this, we can formulate some other formula as well. According to Ohm's law, R equals V divided by I. Hence, I equals V divided by R. If we substitute V by R for I, we get H equals I square RT is equal to V by R into V by R into RT is equal to V square T by R, that is H equals V square T by R. What if the current in a circuit is doubled? We know H equals I square RT. If current is doubled, we get H equals 2I into 2I into R into T is equal to H equals 4I square RT. That is, heat becomes 4 times on doubling current. What if the resistance in a circuit is doubled? On doubling resistance, current becomes half. New current is equal to I by 2. Heat equals I by 2 into I by 2 into 2R into T is equal to I square RT by 2. That is, heat becomes half the former on doubling the resistance. We make use of different devices that makes use of heating effect of electricity. The electric heater, the soldering iron, the water heater, etc. are examples. In all these devices, there is a heating coil made of nichrome. Nichrome is an alloy of nickel, chromium, iron and manganese. The nichrome has so many advantages. It has high resistivity. It has a high melting point. It can remain in red hot condition for a long time without getting oxidized, even if it comes in contact with air in the red hot condition. Microwave oven and induction cooker are devices that produce heat energy using electrical energy without using heat coil. These devices make use of eddy current. Just observe the circuit. When the switch below the bulb is switched on, current gets 2 paths. One through the bulb having a high resistance and the other through the switch S, which has negligibly small resistance. When switched on, the current goes through the path S, the switch which has no resistance, and does not pass through the bulb which has high resistance. Due to lack of resistance, current increases very much and the wire becomes red hot. This is what we call short circuit. Just take a look at this. When 2 wires come in contact, a path of no resistance is created, due to which very high current flows. It is a high current which created the spark. In houses, offices or factories, if you make a large number of electrical appliances to work, current in the circuit will increase very much. This is called overloading. Both overloading and short circuit will produce fire attack or some other danger. Safety fuse is a device that protects us from such dangers. The fuse wire, which is the main part of the safety fuse, has a low melting point. Whenever there is current through the fuse wire, it gets heated. But this heat is radiated to surroundings. When there is a short circuit or overloading, the current increases very much. The fuse wire gets overheated. As a result, the fuse wire melts and breaks the circuit. The current in the circuit depends on the amperage of the devices. Hence, we should take proper care to see that fuse wire of appropriate amperage is being used. In olden days, we depended on oil lamps during the night time. Instead of using torches or bulbs, people in those days depended on burning of dried coconut leaves or such sources. But what a drastic change has come into play with the discovery of the idea of the lighting effect of electricity. At the time of the discovery of the lighting effect of electricity, we were depending on filament lamps alone. It was Thomas Alva Edison who discovered the lighting effect of electricity. The filament lamp makes use of a tungsten filament. When the current passes through the tungsten filament, it becomes white hot and emits light. Heat is also emitted. In fact, In the case of a filament lamp, there is a great loss of energy in the form of heat. Filament lamps are also called incandescent lamps, since the filaments glow with heat. Tungsten metal has many special features. It has high resistivity, high melting point, and high ductility. The high ductility enables tungsten to be drawn into very thin wires. The filament can remain in white-hot condition for a long time and continuously emit light. The bulb of an incandescent lamp is filled with inert gas or nitrogen at low pressure. This reduces the rate of evaporation of the filament to a high extent. Slight variations in temperature do not bring considerable changes in the expansion of nitrogen. A major amount of electrical energy we supply to a filament lamp is lost in the form of heat. Hence, the use of filament lamps is to be minimized for the sake of saving energy. Now, let's familiarize ourselves with the discharge lamp, which is another form of lamp. Take a look into the parts of a discharge lamp. Let's see how a discharge lamp works. When electricity is supplied, the gas in between the two electrodes gets ionized. These ions will move fast and collide with unionized atoms. Due to these collisions, the electrons in the atoms get excited. These electrons try to come back in order to attain stability. During this process, the excess energy is released in the form of light. Depending on the nature of gas filled in the tube, the color of the light emitted varies. There are many types of discharge lamps. Fluorescent lamp is one among them. Certain substances are capable of absorbing radiations of lower wavelength and re-emitting them as visible light. This ability is what we call fluorescence. Such substances are referred to as fluorescent substances. Inside a glass tube, you can see a white coating. This is a fluorescent material. The heating coils seen at the ends are coated with thorium oxide. The coils get heated and emit electrons. These fast-moving electrons collide with non-ionized molecules of mercury vapor. These collisions produce ultraviolet rays. The fluorescent materials absorb the ultraviolet rays and re-emit them as visible light. A high voltage is always essential for the starting of discharge in fluorescent lamps. It is the electronic ballast that will supply this high voltage. This electronic ballast converts 50 Hz alternating current into high frequency alternating current and supplies it to the lamp. The blue light containing the ultraviolet rays can also be used to trap insects. It is also used in banks to identify fake currency notes. Compact fluorescent lamps, better known as CF lamps, are designed to work in low power but to give more light. The working of a CF lamp resembles that of a fluorescent lamp in many ways. At the top of a CF lamp, you can see a white-colored top. This has an electronic circuit which converts 50 Hz into high-frequency alternating current and supplies to the coils of the lamp. The mercury vapor filled inside the fluorescent lamp and the CF lamps are harmful to the environment. The fluorescent materials are also harmful to the environment. So, when you throw out a used fluorescent lamp, you are actually inviting danger. The accumulation of such used lamps is a major threat to the environment. It's our duty to know about the safe handling of such lamps and to teach others about it. Light-emitting diode, known as LED, is capable of overcoming all the limitations of discharge lamps. The LED plays a vital role in our day-to-day life. It has so many advantages. Since there is no filament, the loss of energy in the form of heat is minimal. Since there is no mercury, it is not harmful to the environment. Besides, the amount of electrical energy needed is very little. Arc lamps are the lamps we use for rescue work, cinema shooting, etc. The main part of the lamp is two carbon rods in a glass tube arranged in such a way that they are always at a fixed distance. When applying potential difference between them, a glow is produced in between them. This glow produces light. Now we can say beyond doubt that the lighting effect of electricity has made our life glow with light.